Have you ever pondered on the true might of the universe, the colossal forces that shape galaxies and their celestial bodies? As we stand on the threshold of the cosmos, we witness a spectacle of grandeur, a cosmic ballet choreographed by forces beyond human comprehension. This is a universe of immense complexity and stunning beauty, a cosmic stage graced by stars, nebulas, and galaxies, each playing its part in the grand cosmic dance. Yet at the heart of this dance lie entities of unfathomable power and influence. These are the supermassive black holes, celestial giants that command galaxies. They lurk at the heart of galaxies, their gravity sculpting the galactic landscape, influencing the birth and death of stars, and even shaping the destiny of entire galaxies. Today we delve into the enigmatic world of supermassive black holes, the celestial giants that command galaxies. So what exactly are these supermassive black holes? Let's delve into the heart of this cosmic mystery. Supermassive black holes, as the name suggests, are the largest type of black holes. They're not just large, they're incredibly huge, with a mass that can be millions or even billions of times that of our Sun. Imagine, if you will, a celestial object of such immense proportions that it warps the very fabric of space and time around it. Now let's get to know the two key parts of a black hole: the event horizon and the singularity. The event horizon is essentially a point of no return. Once anything, even light, crosses this boundary, it can never escape the black hole's gravitational pull. Inside the event horizon lies the singularity, a point where all the mass of a black hole is concentrated. Here, the laws of physics as we know them cease to apply, and space and time become incredibly distorted. So, how do these gargantuan entities come into existence? The birth of a supermassive black hole is a cosmic event of epic proportions. When a star significantly larger than our Sun exhausts its nuclear fuel, it collapses under its own gravity, creating a supernova explosion. The remnants of this explosion can then condense to form a black hole. But the story doesn't end there. These black holes constantly grow by absorbing surrounding matter such as gas, dust, planets, and even other stars. When two black holes collide, they merge to form a larger black hole, sending gravitational waves rippling through the cosmos. The existence of supermassive black holes reminds us of the incredible diversity and scale of the universe. These celestial giants, with their mind-boggling mass and gravity, challenge our understanding of the universe and its laws. These entities, millions or billions times the mass of our Sun, are indeed a spectacle of cosmic proportions. Now let's delve deeper into the unique properties that make supermassive black holes truly fascinating. To begin with, one of the most striking characteristics of supermassive black holes is the immense gravitational pull they possess. Imagine a force so strong that nothing, not even light, can escape its clutches. This is the reality of a supermassive black hole, a gravitational pull so intense that it warps the very fabric of space-time around it. Next, let's consider the intriguing phenomenon of time dilation. Time dilation is a consequence of Einstein's theory of general relativity, and it becomes particularly noticeable near a supermassive black hole. This means that time near a black hole moves slower compared to further away. Picture this. If you were to watch a clock falling into a supermassive black hole, you would see its ticks getting slower and slower. Quite mind-boggling, isn't it? Lastly, another fascinating characteristic of supermassive black holes is the emission of jets of particles at near light speed. When matter falls towards a black hole, it doesn't fall straight in. It spirals in, forming what we call an accretion disk. The intense gravitational and magnetic forces at work within this disk can catapult some of this matter outwards in the form of high-energy jets. These jets shoot out at nearly the speed of light, making them some of the most energetic phenomena in the universe. Each of these characteristics, the immense gravitational pull, the time dilation effect, and the emission of high-energy jets, is not just fascinating in and of itself. It also has profound implications on the black hole's surroundings, influencing everything from the behavior of nearby celestial bodies to the very structure of galaxies. These characteristics not only make them intriguing, but also have profound implications on their surroundings. So, how do these celestial behemoths hold sway over entire galaxies? Supermassive black holes, the silent, invisible giants lurking at the centers of galaxies, play a surprisingly active role in shaping their cosmic neighborhoods. They are not just destructive forces, they are also cosmic sculptors, fashioning galaxies into the myriad forms we see today. To understand this, let's first consider the scale. Supermassive black holes can contain millions, sometimes billions, of times the mass of our Sun. This colossal amount of matter generates an equally enormous gravitational pull. It's this pull that holds galaxies together, keeping the stars, gas, and dust from simply flying off into space. Now you might be thinking, but doesn't gravity just attract? How does a supermassive black hole help form structures in a galaxy? Well, it's a bit more complex than that. The gravity of a supermassive black hole doesn't just pull things in, it also creates a dynamic environment where gas and dust swirl around at high speeds. This movement generates heat, and where there's heat, there's energy. This energy can trigger star formation. Here's how. When gas and dust get close to a black hole, they start to heat up. This heat can cause the gas to expand and, under the right conditions, collapse under its own gravity to form new stars. In this way, the presence of a supermassive black hole can stimulate the birth of stars, contributing to the stellar population of the galaxy. But the influence of supermassive black holes isn't limited to their immediate surroundings. They also play a crucial role in galaxy mergers, which are dramatic events where two galaxies collide and eventually merge into one. During these cosmic dances, the supermassive black holes at the centers of the colliding galaxies can interact in ways that help determine the shape and structure of the newly formed galaxy. In some cases, the gravitational pull of the black holes can cause gas and dust to be funneled towards the center of the merger. This can lead to a burst of star formation, creating a bright, active galactic center. In other cases, the interaction of the black holes can send shock waves rippling through the galaxy, triggering star formation in far-flung regions. So while they may be invisible and enigmatic, supermassive black holes are far from passive. They are active participants in the life of their host galaxies, influencing their formation, evolution, and structure. They can stimulate the birth of stars, shape the outcome of galaxy mergers, and create complex galactic structures. Their influence extends far beyond their event horizon, shaping the very fabric of their host galaxies. Indeed, supermassive black holes are more than just cosmic oddities. They are astronomical titans wielding an influence that extends far beyond their own gravity wells. These celestial giants are not just elements in our cosmic landscape, they actively shape it. Let's take a moment to recap. We've learned that supermassive black holes are quite literally massive. They contain millions, sometimes billions of times the mass of our own Sun, yet they reside in a space not much larger than our solar system. This concentration of mass creates a gravitational pull so strong that not even light can escape, hence their famously dark appearance. We've also touched on the characteristics of these black holes. They are voracious eaters, consuming anything that strays too close, from stray asteroids to entire stars. Yet they also act as cosmic lighthouses, spewing out jets of high-energy particles that can stretch thousands of light years into space. Their influence on galaxies is profound. They reside at the heart of most galaxies, including our own Milky Way, acting as celestial anchors. Their gravity shapes the orbits of stars, essentially holding galaxies together. Despite our growing knowledge, supermassive black holes remain enigmatic. There are lingering questions that continue to puzzle scientists. How did they form? How did they grow so large? And what role do they play in the evolution of galaxies? Current research is trying to answer these questions. Scientists are using various tools, from powerful telescopes that can peer into the heart of galaxies to sophisticated computer models that attempt to recreate the birth and growth of black holes. Yet, mysteries remain, reminding us of the vastness of what we don't know. Supermassive black holes are not just a testament to the complexity of the universe, but also to our enduring curiosity to understand it. As we continue to unravel the mysteries of these cosmic juggernauts, we gain profound insights into the workings of our universe, reminding us of our place in this grand cosmic theater.